Hello and welcome to Makaut CSE. In this video, we will embark on a fascinating journey into the world of discrete math. This is for the 4th semester subject, a core subject of BTech CSE and IT student for the GATE examinations, for the AI ML journey and the mathematics of the AI, everything's. So this subject forms the foundation for understanding the various computational concepts like the algorithms, data structure and more. Today, we will give you a brief overview of the entire syllabus, setting the stage of our detailed chapter-wise exploration from the sets, relation functions to the graph and trees. Discrete mathematics has it all. Each topic is carefully structured to ensure a seamless learning experience. This overview will give you clarity about what to expect in the upcoming videos. So stay tuned and prepare to dive into this essential domain of computer science. Make sure to subscribe and hit the bell icon to stay updated. So let's begin. At first, set, relation and function. Discrete mathematics begin with the fundamental blocks. Sets are the collections of distinct elements, also governed by the operations and laws like the union, intersection and difference. Relations define how the elements from one set relate to the another. Just like function, you can say function is a special case, so including the equivalence and the partial ordering. Functions on the other hand map the elements between the sets. We explored the bijection, inverse, composites and their significance in the computer science. The concept of finite and infinite sets lays the groundwork for understanding the countability and uncountability, crucial in the algorithms and data theory. Cantor's diagonal argument and the power set theorem highlight the richness of set theory. We will also touch on the Schroeder-Bernstein, a vital theorem. So it gives the result in set cardinality. So master this topic is crucial for tackling the advanced subject in the programming and databases. So now, principle of mathematical induction. Mathematical induction is the cornerstone of the proof techniques in the discrete math. It allows us to verify the statement over infinitely many cases with a simple processes. Starting with the well ordering principle, we will examine the recursive definitions and their applications. The divisive algorithm provides the insights into the prime numbers and divisors essential in the cryptography. Euclidean algorithm for finding the greatest common divisor GCD is another critical concept. We will explore the fundamental theorem of arithmetic, which states every integer can be uniquely factorized into the primes. This chapter bridges the theory and the application, also enabling you to solve the real world problems from the modular arithmetic to the algorithmic design. A strong grasp of introduction and recursion is a must for tackling the logic and the computational problems. So now, basic counting techniques. Counting is a fundamental skill in the computer science, and discrete mathematics introduces the efficient techniques like the inclusion-exclusion principle, which helps to count the overlapping sets. The pigeonhole principle provides the insights into the situations of guaranteed repetition, useful in the algorithms and optimization problems. We will also delve into the permutation and the combination, the powerful tool for enumerating the arrangement and the selections. These techniques form the foundation for the probability theory and combinatorics. Applications span across hashing, network design and cryptography. Mastering these tools will make you to adapt at solving problems involving the discrete quantities, ensuring the precision in the logic and computation. So whether designing algorithms or analyzing the complexity, counting techniques are indisciplinable. It is also helpful in the IP addressing concepts. So now, introduction to propositional calculus. Logic is the language of mathematics, you can say, and the propositional calculus is a grammar. We begin with syntax and semantics, understanding how the statements connect through the basic logical connectives. truth tables are introduced to verify the validity of the propositions. Logical equivalence and the loss of logic enable the simplification and the transformation of the expressions. We will explore the quantifiers which generate or generalize the propositions over sets. Proof techniques like the forward proof, contradiction, contrapositions are the heart of mathematical reasoning. This chapter emphasizes the problem solving, fostering the clarity and the precision in the thought. Mastering the logic is critical for programming as it directly applies to control structure, databases, and formal verification. So the two things, one is the propositional logic and the combinatorics is very important two chapters in the discrete mathematics subject and in the field of computer science for the higher study also. So now, algebraic structures and morphism. Algebraic structures like the groups, rings, fields are the key top tools in abstract mathematics and computer science. Starting with binary operations, we study the semigroups, monoid, and groups, exploring their properties and real-world application. Quotient structure and congruence relations lead to the modular arithmetic. Integral to cryptography. It is a very important chapter for cryptography related subject. Boolean algebra provides a framework for digital logic, enabling the circuit design and simplification. Normal subgroups and morphism connects the algebraic structures, showcasing their symmetry and the transformation. Boolean functions in disjunctive and conjunctive normal forms are critical in the logic minimization. This chapter ties the abstract concept to tangible computing applications, depending your analytical and problem solving skills. So now graphs and trees, the final topic. So the final topic, graph and trees, introduce the indisciplinable and also in the computer science field. The graph represent the relationship with properties like the degree, connectivity, and the paths forming their foundation. Euclidean and Hamiltonian works demonstrate the traversal problems. You can also see this graph and trees chapter in also in the subject data structure and algorithms. So these are similar. So while the graph coloring aids in optimization tasks like the resource allocation, trees, a subset of graphs, have the application in the sorting, searching, and data compression. Topics like the weighted tree, prefix code, and shortest path show their practicality. Articulation points and bi-connected components enhance the network design and resilience. This chapter bridges the theory and the application, equipping you to solve the problems in networks, AI, and algorithms effectively. So let's wrap up our brief overview of discrete mathematics, from the fundamentals of sets to the complexities of the graphs and trees. The subject offers a wealth of knowledge for aspiring computer scientists. In the upcoming videos, we will dive deeper into each chapter, breaking down the concept step by step with examples and applications. So stay tuned and don't forget to like, share, and subscribe to Makaut CSE. Let's make the learning discrete mathematics an enjoyable journey together. Until next time, keep exploring and keep smashing your goals.